Hello everyone, my name is Zheng Yuan, and I'm going to introduce my product. The product is called a distributed voting system, which is based on Ethereum. Okay, so firstly, let me introduce the motivation for this product. Okay, this is a graph for a traditional web application. Okay, so a traditional web application usually depends on a central server, and this web application will be hosted on a hosting provider like AWS or a VPS. And all of the clients or all of the users will interact with this one central application. And the clients can be a browser or a or just some simple API. And when a client makes some request to the server will do the transactions. Like uh, uh, it will talk to the database or the cache, and then to read or update the database and then serve the client. Okay, so yeah, as you can see all of the details uh, in this graph. However, uh, this framework may have some problems in some scenarios. For example, if you are using a voting system, how can you make sure that the central server is always stable and always has the correct information? Okay, you might there might be some solutions like uh, making some replications of the database and make the server more secure. Okay, but it cannot perfectly solve the problem because the users always have to interact with the central server, okay, instead of themselves, and they don't know if the database on the server is stable or not. Okay, they don't know that. So what if the owner of the server or some hacker made some malicious changes to the database? The users will never know that if that happens. Okay, that's why we want to build a decentralized web application. Okay, so with the help of blockchain technology, we can build decentralized applications which can make the system more secure and more stable. Okay, so in a decentralized application, the data, all of the data or the transactions are stored in a blockchain, and all of the users can have a local copy of the blockchain. And Ethereum is a global open source platform for decentralized applications. And every few transactions that occur in the Ethereum network are packaged into blocks, and each block is linked to the next one. Okay, as you can see from this picture, there are many blocks and they are linked together. And every user or every client will have its own instance of the web application and also the blockchain. Okay, so in this case, the users or the clients will not interact with one central server. Okay, they can just interact. They can directly interact with their local application or their local blockchain. Okay, and then it can make the system more secure. Okay, because in this case, the users will not rely on any central server. They have the information of the whole blockchain. Okay. So next, I will show you how to run my application. So firstly, we need to install some packages. The first two packages are npm and Node.js. So npm is a package manager for Node.js applications, and Node is a application for Node.js. and you can install them from the official site. After that, we need to use some packages, and we just need 3 packages in this application. Gnash CLI, which is a command line tool for Gnash, and Gnash is a tool which creates a local blockchain and also some local accounts. And SOLC is the compiler for Solidity, because Ethereum applications need to be written in Solidity, which is a language. Okay, and Web3 is a library for Ethereum web applications, and you can install the applications using npm install. Okay, and then we can run the Gnash CLI, and then it will create a local blockchain and also some local accounts. Okay, and yeah, note that you need to keep this Gnash CLI running, and you can see the output in the future. Okay, and then we can deploy our contract. Yeah, by the way, a contract or a smart contract is just a program that runs on a Ethereum network. Okay, and there might be many different contracts in a blockchain or in a Ethereum network. So how to make sure that you are running on the correct one? Then you need the address of that contract, right? So I wrote a JavaScript file for you to create a smart contract, and also it will give you the address of the contract. Okay, after having the contract, we can open this HTML file in your browser and place this address into the first box, and then click set. After that, you will have after that you can vote for any candidate that you want to vote. Okay, let me show you how to run this. So firstly, we run the Gnash CLI. And you can see that we have some local accounts. Okay, and it also creates a blockchain, and it is running now. So, and then we need to create the smart contract, node contract.js, and we have the address for this contract, and then open this file, and then you can see that there is no number here. Okay, because we don't know which contract that we are going to run. So we place the contract address here, then click set. Okay, so now this is a new contract, and so there is no votes yet, and then we can do any vote that we want. So let's say JSON, then click, and let's try some votings. You can see that every transaction is recorded here. Okay, so this is this Gnash CLI will print the logs for every transaction. Okay, and you can create more than one contract. Okay, so currently the votes are 3 to 2. Okay, and if we create another contract here and copy the address, click. So this new contract, there's no votes yet. Okay, and then you can do the voting. And then if we go back to this contract, it will have the same voting numbers as before, right? Because the blockchain is immutable. Every transaction is recorded into the blockchain. Okay. Okay. That's all. Thank you.